Ladies and gentlemen, today I'm going to discuss about collection framework in Java. So generally it can be called containers because they can keep elements. Each container has its own structure which allows you to manipulate elements in it. Here uh, we have two branches of collections. First, collections, then the second is map. All collections implement interface iterable. Iterable means you can follow through the collection uh, or all elements and, for example, filter or do something with an element in uh, on on current stage of iterations. The top of hierarchy is collection. It inherits by inherited is inherited by list set queue. You can implement your own collection, give it name, but interfaces. The main interfaces are set, list, queue. A lot of containers already implemented in Java core. The first about these branches. Set means set means you cannot put the same element twice. What does it mean, same? Same means it has internal structure, the same internal values of all fields, all of necessary fields. Okay. Um, List. It can contain any kind of elements. No, any elements in of the specific type or different type that can be used. But elements can be repeated, so you can many times put into it uh, element many times. So you can do that. There are a lot of different implementation, not a lot, several already exist. Array list, linked list, vector. Vector is the same as array, but it is thread safe. About multi-threading or parallel programming, we will discuss in this course, but you need to understand something. Array list, linked list. Okay. Queue, very useful structure, usually used to put, for example, messages, elements, and the first idea, last in, first out, or first in, last out, to handle, for example, sequence of incoming events or something like that. Okay, about next things. List hierarchy. So we just seen it. Iterable iterator. On practice, iterable. Iterable allows us to interface iterable. Brings into into it implementation one method, iterator. This method is factory method. It must be implemented in the container. Okay, iterator allows us to go over elements of all collection. Okay. Array list. under hood, it has an array. Array, if you remember properly, has specific amount of elements. The length of the container cannot be changed of array. Yeah, about array. But and this means you need to extend this internal array with more size, bigger size, copy all elements here, and then you can use new instance of the internal array. Okay, a linked list. The idea here, you have special class node which has data and references, all and references to the next element or and previous element. Here is this container named bidirectional list. When we add new element, we also add reference data, next, pref. We have first element and last element. We can name it, for example, head, tail, first, last. It's your own opinion, okay? How to name that? For it's here I will name it first and last. Okay. Then we added the first element. We put the reference into the first. Then we end to the last reference. If we add new element, we must reference it next of the first element. We will reference it to the next. Here, previous will be referenced to the previous node, and here and last must be changed. Okay, to the last element, and so on. It allows us to add a lot of elements until until we have memory. Okay. There are two special classes, utility classes. All of them has only static methods, like math, class math. It has no one non-static methods. The same arrays and collections. Arrays has a lot of methods to handle collections like sorting, to string, and so on. Okay. Or extend array, or shrink array, and so on. Collections, the same idea, because all containers like list, set, queue implements collection. So the collection can have a lot of methods to which help helpers methods to handle collection. Okay, like for each, like creating new instance, like do something additional. Okay, usually the methods are creators. Okay, let's go ahead. First of all, I would like to create new. Yeah, when you walk this collection, you use please. Almost always use interfaces. Don't work on general class on the class. Use interfaces. Okay. New class. Test list. Okay. How to create a list? Main, we can specify. First of all, a list is generic. What does it mean, generic? Generic, in generic, you need to specify. The type of the class. If you don't do that, row list. You can create new, for example, array list. Okay. Okay. You can put there any kind of element, any type of element. Row list, add. And you can edit. New object. Okay. Okay. You can put here, for example, a string. You can put here, for example, a character. You can add here example number. Any number. Okay. Of course, usually you don't need to do that. Usually you need to have homogeneous container, which allows you only put into only specific type and its inheritors. Okay, so here you can use, for example, collections class to, for example, sort. You must specify put here a list. Okay, sort with comparator. Okay. Then what another? Asli for Q at all, and it will return. No. Collections cannot be. It's not static at all. New. No. For example, list. Okay. Row list. At all. What does it mean? Where? Mm. Mm. Here we must specify new elements. Put here, for example, A5 and so on. Okay, so these elements will be added into the these elements will be added here. Okay, like any other method can be used here. Okay, there. When you need to homogeneous container, for example, string, okay, you can use strings, okay, new, for example, array list, and you can add many elements here. You can use other way to other way to add here. You can use it list of and specify elements in the method. Okay, for example, A, B, C, for example. Yeah, C. Uh, can we add after that elements additional strings? Add, for example, D. Will it work or not? Here, immutable object is modified. Be careful. A list of returns immutable collection. Immutable list. What does it mean? The state of the list cannot be changed, but if elements in it are not mutable, you able to change their state. Okay, here string is immutable type. Yeah, so you will not be able to change no elements, no state of the collection. It's very important to remember. Okay, here immutable. Mutable. So here to add. Ой-ой-ой. Unsupported operation exception. You cannot add anything here. Okay. Mm, you can you for example let's create something. Yeah. Another way. Arrays to list. No. As list. As list, and here you can at A, B, C. Okay, yes. Okay, this list. This list mutable. Different ways. But this list returned is mutable. As list returns array list. Okay, so here we can modify list at D. Works fine. Arrays. Oh, it's not necessary. List. Stop. As list. Array list. Okay. As you can see, it's another class. Array list. Immutable. I forgot of it. Okay. Mm, okay. Uh, yeah. See. Okay. You can add null here, for example. Null. And it's okay. Okay. Can I remove? How to remove elements? Okay, list remove. Remove. No. You can remove by index. Uh, uh, remove by index. Stop. Stop. Exception remove. One export. Oh, it's not. Uh, I forgot. Forgot. Uh, um, list. Um, new. New. Uh, uh, new array list. And here, list. Yeah. How it will work? Here we have list. Add all. We can use operation add all, but I can put any collection as argument. And in this case, you can it will copy all references, not elements. It will not clone elements. It will copy only references. Okay. Okay. Here we can list, and it will be without null. So it's okay. Add elements as null and remove them. Not all implementation of list allows that. Okay, go ahead. About you can you can you can explore methods which here clear contains all equals. If containers has the same elements, all elements. Get by index. What does it mean by index? Means mm, means uh, list is indexed collection. Very important. Indexed collection. Array list, linked list are indexed. You can access element by index. Question for you. Which of two containers, array list, linked list, works in this case faster? Hmm? Can you hear me? Ladies and gentlemen, do you hear me?
Yes.
So, question. We have array list, linked list, and we want to get element by index. Which of them will walk faster? Array internally is array list, linked list sequence of nodes. To get element by index, which of them walks faster? Mikhaila, Anna, Alex, Anastasia.
Probably linked.
Linked. What should we do in linked list? We need to have first element. We need to organize loop. Yeah. First, second, third, and so on. Because of array implementation in array list, we just point to the specific element into array. Okay. So here, getting element by index much significantly faster in array list. Be careful. Just here, you need to ask yourself, what do container, if we to get element or to add element and so on, what must do container in one case, in second case, and so on of its usage? Okay. About comparison of the element, just give me please couple of seconds. I'll try to find here must be here. CPP ODS binary tree linked list binary tree solution array other test. Okay, maybe here. Sorting. Times no. Personal size. Oh, I found it. Just a moment. Example. The game. Russian roulette or something like that. Persons create cycle and play Russian roulette. Choose a number, for example, K equals 3, and each of which counts the from 1 to 3, and who has 3 loses. Okay. 1, 2, 3 lose. 1, 2, 1, 2, 3 lose. 1, 2, 3 lose. 1, 2, 3, lose. 1, 2, 3, lose. 1, 2, 3, lose. 1, 2, 3. No, no, no. Mm, 1, 2, lose. 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 Winner. Okay. We emulate this game using two containers, array list and linked list. We need to delete every time until it's empty. Okay? No, the size is one. Is condition where container algorithm must stop. Okay, remove. We can have several ways to implement this algorithm. The first rate we can use indexes access. Linked list, array list, doesn't matter. List is indexed collection, so array list, linked list works fine with indexes. It means that means works with it, allow us to do that. So how we do that? We created loop until size greater than not until size not 1. Okay. If we if it has the last element, so we start e from 0 and so on. Yeah. Other way, use iterator. On the practice, I explained how does it work, and we do almost the same until size, while size greater than 1. We use condition it. If iterator has no elements to iterate, we create new iterator. So we reach the end of the list, so we create new iterator and start the game. Here, here the test, well, here the test which run many times, can be run many times, and collects as a result, time result. Let me start it from one times, and we use 1 million elements. Okay. Oh, no. How much elements here? Max size 5,000. Okay, car is equal 3. We can use another car. Let's run it. Let's take a look on the result. Remove by index on array list. 124 seconds. By linked list, 833. If we more than array list faster than more than 6 times, yeah? almost 7 times, almost. But if you remove by iterator, we have 3 seconds and more than 100 seconds. Why? Let's return 10, experiment 10 times. And run it. Calculate average time. One second. Millis. 100 times. 7. What's the algorithm? I want us to discuss about that. And I want you to share your opinion why we have such results. Please, don't hesitate. Your ideas. Mikhailo, Anastasia, Alex, Ruslan, Anna. What do container if it need to remove if it should remove element? What do array list? It need remove element this, and container has a lot of elements there. What should it do, array list? It need shifts to shift elements one by one. Yeah. Okay. If it indexed access, it find it very fast. Yeah. Very fast. But a linked list has sequence of elements, and it have to must iterate over elements. Okay, if it indexed access, it always start from 0. First iteration, it start 1, 2, 3. Okay, we need second index 6. Okay, it start 1, 2, 3, 4, 5, 6. No, 0. From 0. Okay. It removes. It's every time goes starts from 0. Here it must have many loops to understand what the element, what the index of the element. Here it array list find it fast. But to remove an element, It must just reassign references, linked list. But how many times it costs? A bit. Here we have a loop to shift elements. That's why a lot of iteration gives us linked list loses. Lose of linked list. Let's go to let's discuss about iterator. Array list, a linked list. We need to have third element. Okay. V points in array list automatically to the 0, 1, 2, no? The third. Yeah. Here we started iterator also. Yeah. Okay. Iterator has first element, second element, third element. Okay, it points here automatically. Yeah. Here, array list, we need to remove shift all elements. Shift. In linked list, we need to just re-reference. When new iteration starts. In linked, in array list, it starts here, but it can use index. Yeah. Раз. 1, 2, 3. Okay, here 1, 2, 3. We automatic go. We just need to couple of iteration, not iterations. Yeah, iterations of internal loop to find next element. Next. The same as in array list. The same. But linked list do not need to shift elements. All elements. It just references to element. And yet again, array lists need to shift other elements. So in this case, we have the fastest algorithm, significantly faster. Here, 57 times, 58 times faster. Okay. Here, 12, if I'm 12 or 12 times. Array list, linked list by array list wins. Bet. Linked list 12 times was the specific algorithm. But array list loses linked list in many 100 times. If you use list, you don't need indexed access, always use iterator. Always use iterator. Okay. Any questions here?
No questions.
Good. About set. Maybe here I have examples about set. Sorting types. is binary tree, binary tree conversion, sorting, data types. No. Okay. Go ahead, set. Instead of a list, we can use set. Okay, set, yes, set, and here we can use one of implementations of set. There are main implementations. It's tree set and hash set. Hash set. Okay. Row list, shift 6, and here we use correct name set. Sort, sort, row set. Okay. Please take a look about ordering of the elements. Object A instead of new object. Object new string, then this character here, then object, then numbers. So hash set does not keep or ordering of addition. You must remember. Okay. Here we can use also the same. We can here use also set and here set off. Okay. Set. Yeah, set. No. Arrays set. No. Set all. No way to do that. Just like that. Okay. And here we also will have, but we can use new hash set. It matters like it can be like collection. Hash set also collection. Yeah. Okay. New. And just a moment. Let's comment it. And what happened here? We have null ABC. A, B, C, C. Only one C was keep it. What happened if we need to, if we use, for example, instead of hash set, we can use, for example, tree set. Set, tree set, here, tree set. Okay. Tree set here we will name and rename all occurrences. Here hash set. Okay. Run it. It'll got error. Why? We cannot put the first put null. When we put null, we will have error. Okay, why? Because tree set is ordered set. And it does not allow use nulls. Okay, but and if we will use these elements, it's okay. If we use this element and use, for example, not hash set and will use tree set, we will also have error. Why? Okay, we have row set. Okay, we'll do the next row tree set and here tree set. Here we will got error. We will get here class cast exception because tree set is container which keep elements sorted. In this case, all elements which we put into this container must implement comparable, or this tree set must have comparator. So if we put here new comparator, O1 objects compare O1 O2 they must implement comparator. Object cannot be compared. Yeah, object cannot be compared. Why? Because it's not implement comparator or comparable. So we will not be able to do that. It will work fine for any of homogeneous collection which allows us to do something. Yeah, for example, we can use tree set for strings and define new comparator. We can use, for example, comparator reverse order. Oh, no, I forgot. No, or elements or comparator. So but we can do another thing, tree set at all. Yeah, firstly we set comparator and then we add all elements. Okay, go ahead. Yeah, if it again. No, I will not repeat myself again. Okay, next. Set strings. Set of strings. Link. No. Set new linked hash set. Set hello strings. Yeah. Oh, preset. Hello. What happened? Okay, I know. And no. Arrays is list. List. Here we will add a list. Okay. Okay. No. Set out. ABC no keeps ordering of addition. The way we add elements, it keep it. B, you need be careful with hash sets. All elements which you put into hash container must implement hash code method. What if we want to use, for example, some person means person which has two fields, string string name, okay, int age, okay. We have constructors okay, to keep it working, and string, okay. To string constructor with all parameters and more. What happened if we add the persons into the hash container? Okay, here we remove unnecessary.